What we have here, guys, is a particle moves in a straight line so that at any instant its acceleration is in magnitude half its velocity. So, what we're going to write down here is that A equals a half V. Now, if its initial velocity is 3 meters per second, find correct to one decimal place the distance it describes in the fifth second. Distance in the fifth second. Okay. It wants distance related directly to time. Would you agree with that? Distance related to time. Now, here's how you make the right choice. Okay? If I use A equals to V dt, that is velocity with respect to time, isn't it? That'll give me a velocity equation with some type with v on one side and t on the other when I solve it. Yeah. The the A equals v times the VDS. What type of answer will that give me when I do it? It'll give me a v in terms of S answer, or an S in terms of v. Does either one do the trick for me though? Does either one get distance related to time? No, but remember in the last part, this one here has a knock-on effect where you can then turn v into the SDT in terms of some sort of t equation, and then at the very end you're going to have S in terms of t. So, do you understand the pathway there? That this one, the dVdt one, has a double function. It gets you phi in terms of t, and after that, it will get you S in terms of t once you integrate again. The other one, however, will only get you phi in terms of S. That's probably the most important 20 seconds you're going to hear regards to this full chapter. Okay? So, what's going to happen next, guys, is we're going to choose A equals to V dt. The V dt equals a half V. 1 over V dV ends up to be dt. Integrates. What are my limits? 3 and 0, t and v. ln v from phi to 3 ends up to be t from t to 0. ln v minus ln 3 equals t minus 0. Using the subtraction rule of logs, ln v over 3 equals t. Then remembering that ln actually means log to the base e, what can we do next? Anybody? Next step. Phi over 3 equals e to the power t. Wait a second. Did I memorize a half? Forgot the half. Sorry about that. So as a half v, wasn't it? So when I brought the v underneath, I should have left the half up there. Okay. So it's e to the power of half t. Then bring the 3 up. Phi equals 3 e to the half t. Now, here's an interesting way of doing this one. Velocity can change into what, guys? What can velocity change into? Why do I keep doing that? What can velocity change into? I said it earlier. It's a derivative. What do you say? ds dt. You can change into ds dt. So, what we can have here is that ds dt ends up to be equal to 3e to the half t. I want the distance described in the fifth second. What does the distance described in the fifth second mean? You'd need the distance covered after 4 seconds, and then the fifth second means t starting at t4 and ending at t equals 5, because 0 to 1 is the first second, that's the second second, that's the third second, that's the fourth second, that's the fifth second. Starts at 4, ends at 5. Another way to do it would be to get the total distance after 5 seconds, the total distance after 4 seconds, and take them away from each other. But we're using integration. Integration is a very powerful tool. So I'm going to show you a really good way to do a question like this. Here's what you're going to do. We're going to bring 3e to the power of a half t up here. We're going to have ds on this side, and we're going to have t here. We're going to bring in some limits, alright? Now, what it wants is the distance travelled from the fourth to the fifth second. Let t equals 4 be the lower limit, t equals 5 be the upper limit. This has the effect of 5 minus 4, the distance covered in the fifth second. Okay? Then on the other side, we set the lower limit as 0. Why do we set the lower limit as 0? Can anybody tell me? This 0 means that you're taking no previous distance into consideration. So, and you put s as your upper limit. So this means that the distance you're talking about from 0 to s, it's just going to turn out to be s integral s to 0, and then it's just going to turn out to be s. What the effect of the 0 does is it isolates s on its own, and then the 5 and the 4 is basically taking the distance covered in 5 seconds minus the distance covered in 4 seconds. That's basically what it's doing for us. Okay? So what we get when we integrate this is what we're going to get is 3. That never changes, the exponent, doesn't it? Not, it's the same integral. We got to divide by the power, which is divided by a half. 3 divided by a half, anybody? 6. And then we have it from 5 to 4. So we're going to get s here equals 6e to the 5 over 2t minus 6e to the 4 over 2t. 4 over 2t? 2t. Oh, sorry, there's no t, because t is 5 and t is 4. So that's your answer there, guys. Plain and simple, right? Now, a car freewheeling on a straight road experiences a retardation or a deceleration which is proportional to the square of its speed. Proportional. A equals minus v squared, but it says proportional. So what happens when it's proportional? Constant. We'll go with k. Minus kv squared. Now, its speed is reduced from 20 to 10 in a distance of 100. Calculate the time taken to travel the 100. That's one to think about. It wants me to calculate time. And I think we can get the time using the speeds, can't we? The time using the speeds. But we're also given a distance. So we're given the full array. Now, it says distance. That doesn't necessarily, it just means that the distance you travelled from 20 going to 10 is 100, okay? So I think I'm inclined to go the VDT equals, let me see if I just did this right. Yeah, it's a big one. Yeah, I'll go for the VDT first, okay? And then I can always go. I can go the VDT route, and then once I'm done with this question, I'll get phi in terms of t, and then I can always go the ds dt route after that and get s in terms of t. So I should be able to find the time taken to travel the 100 meters using that route there. So what we're going to do is the VDT equals minus k v squared minus k dt ends up to be 1 over phi squared to v. 1 over phi squared to v is phi to the minus 2 to v. Integrates 0, but I started off at 20. Phi and t. Integrates. It's going to be phi to the minus 1 all over minus 1 from phi to 20. This is going to be minus kt from t to 0. And then what we're going to get here, guys, is minus 1 over v, because phi to minus 1 all over minus 1 is basically the same thing as minus 1 over v. And then that's minus 1 over v minus minus 1 over 20 equals minus kt. I'm going to multiply, going to isolate v, so it's 1 over v plus 1 over 20 equals minus kt. Now, that's a minus 1 over v, by the way. Multiply both sides by minus 1. Just get rid of that. Get rid of that. Change that to a minus. Get phi in terms of t, and then set that up for ds dt equals a formula with t in it. Get ready to set that up. So you gotta get v on its own. Bring the 1 over 20 out the other side. Kt plus 1 over 20. I'll give them a common denominator. 20 kt over 20. Join the 20s together. Okay. Now once I'm done with that, turn them both upside down. If 3/5 equals 6/10, 5 over 3 equals 10 over 6. I'm just doing that trick there where I'm just going to turn both fractions upside down because the proportions are still the same. So v equals 20 divided by 20 kt plus 1. Okay, that's phi in terms of t. Question relates back to calculate the time taken to travel 100 meters. So I'm going to get s in terms of t now. The phi changes into ds dt. 20 equals 20 kt plus 1. So here we go again. ds equals 20. Now 20, I'm going to break this up into 20 multiplied by 1 over 20 kt plus 1 dt. It'll come apparently obvious why I did that in a second. Okay. You can integrate. And what are your limits? Because 20 is a constant, I'm going to keep it on the outside. 20 kt plus 1, however, has a variable t in it, so it's not a constant. What are our limits? We'll go for, it says that how long does it take to cover, so we'll go for s to 0. And on this one we'll go for 0 to t. This here is going to be equal to s from s to 0. The other one, any ideas for this one here, guys? Any ideas how to integrate that? This one here? ln 20 kt plus 1. Differentiate the part in the brackets, and what do we get? Remember, t is the variable. 20k. Go remember your 20k on the bottom. Okay. Now the 20 and the 20k interact just to become k. And that's from t to 0. This is going to be s equals ln 20kt plus 1 over k minus ln 20 times 0 is just going to be ln 1 over k. 1 second, guys. ln 1 is what, guys? ln 1? 0. Now we're here. We're told that the distance traveled is 100, right? So therefore, we're going to put down 100 equals 1 over k ln 20 kt plus 1. We're now going to isolate t, because the whole point of the question, calculate the time taken to be 100 meters. Now there's a trick in this, guys. 2 minutes, we'll get this covered. What we're going to do is this. 100k equals ln 20 kt plus 1. It's log to the base e. We want to isolate the 20 kt plus 1. So it's e to the power of 100k equals 20 kt plus 1. Bring the 1 over to your side. E to 100k minus 1 equals 20 kt. Isolate t by dividing by the 20k. Now, that's what t is. Now, there's a problem with this, though. What's the problem with this answer? We don't really know what k is. Okay? And that had me puzzled for a long time. How on God's green earth do we figure out what k is? Okay? Go back up. And what I'm looking for is this here. Go back to the top again. Velocity equals 10. Velocity equals 10 at the time t. So remember it says the time taken is t. That's what we're looking for. The time taken to cover 100 meters, it's also the time taken to go from 20 to 10. It's also going to give me the time taken when t equals 10. So what I can do is, I get my 20 kt, this here, and I'm going to put it equal to 10. Because it's the time taken for its velocity to become 10. Now, this here becomes 20 and 10. We can divide both sides by 10, and we're going to get 2 equals 1 over 20 kt plus 1. Our 20 kt plus 1, guys, bring it up. 20 kt plus 1 equals 2. Okay? Or 20 kt plus 1 equals 2. So, where did we have 20 kt plus 1? We sort of had it here, didn't we? Or 20 kt plus 1. So what we could say is that is, we could call that 20 kt plus 1. 1 second. Okay, you can go. Sorry about that, lads. So, this 20 kt plus 1 is the same. That's 2. So 100 equals 1 over k ln 2. K therefore equals 1 over 100 ln 2. And then if we substitute that in here, E equals 100. Substitute in the k value. So the k value is 1 over 100 ln 2. So 1 over 100 ln 2. And this is 20k, so that's also 1 over 100 ln 2. Put all that into the calculator, you get t equals 7.2 seconds.